Howdy, howdy. These are 6-3 notes, the graph translation theorem. Here is a journal choice for your pleasure. Okay, objective and what's the point? We are going to use something called the graph translation theorem today. It's very useful. It's a quick and easy way to graph or get a general form of a graph. And you will use this throughout your math career, so I would pay attention and take good notes here. Okay. This is going to be an activity. It's a graphing calculator activity, and I really need you to participate at home with your graphing calculator on this because I'm not going to run through it on a graphic calculator. We're just going to discuss the answers, and if you don't look at it on your graphing calculator, it's not going to make a lot of sense for you. Okay, so what I want you to do right now is you're going to, oops, didn't mean to do that. Won't let go. Okay, you are going to get your graphing calculator out, and you are going to graph y equals or f of x equals x squared. You're going to take a look at that graph. It should give you a parabola because the graph of a quadratic is a parabola. Then I want you to look at the graphs x minus 4, the quantity x minus 4 squared and the quantity x plus 2 squared. I want you to take a look at those and see what you find out. Then you're going to graph x squared minus 5 and x squared plus 3. You might need to pause the video, jot those graphs down. And then you're going to graph this quantity x minus 3 squared plus 2 and the quantity x plus 4 squared minus 1. Okay, after you graph those, and I'm sure you had to pause the video to do that, you will have noticed something. When there is a number in parentheses with the x and that quantity is squared, you are seeing some sort of movement, and it appeared to be, on the first one we went right 4, and on the second one we should have gone left 2. Okay, on group B, we went down 5, and we also went up 3 on the third one. And on group C, I don't know if you saw this or not, but you went to the right 3, up 2, and left 4, down 1. Okay? Without graphing, then I want you to guess what will happen here. Take a second, jot it down, pause the video if you need to. What hopefully you would have guessed is on A, you should have guessed that you went to the left 5. On B, you should have guessed that you went down 1. And on C, you should have guessed that you went to the left 2, down 5. Okay, so what I want you to do right now is to come up with some rule in your own words to jot down what happens if you have, I don't know if you can read that, x minus h quantity squared. What's going to happen to your graph? What's going to happen to your graph if you have x squared plus k? And what's going to happen to your graph if you have x minus h squared plus k? So jot that down in your own words before I give that to you. If you do this, it might make more sense to you whenever it's your own ideas instead of something I'm just going to provide you, which I will provide you in a minute. Okay, so here's the graph translation theorem. In a relation described by a sentence in x and y, the following two processes yield the same graph. If you take x out and you put x minus h in, and y and put y minus k, that's the same thing as applying a translation THK. Now, we skipped this section in chapter 4, but you have seen this notation in geometry. The big T means a translation, and if you remember, a translation is a slide in geometry. So what we're going to do, H is going to be the horizontal movement, and K is going to be the vertical movement. So if you take x and put x minus h in, and you take y and put y minus k in, that's the same as just translating it h horizontal units and k vertical units. This is more of the notation we will use though. This is called vertex form. You're going to want to memorize this. I prefer the second to the first. Okay? If y is by itself, and I like that because it's ready to graph form, y equals a times the quantity, oh, don't want to do that. A times the quantity x minus h squared plus k. You will want to memorize this. In other words, this is telling you just what you should have written down in your own notes. This is the up or down. This is the left or right movement. And this A, you should know from Algebra 1. If A is positive, it's a smiling face. If it's negative, it's a frowny face. Okay? And if you remember from the direct variation unit, when we had y equals kx squared, k and a are the same thing here. And if you remember, that point 1 comma k was always on the graph. So if it was y equals 4x squared, our parabola was skinnier because you went over 1 and then up 4. So if the absolute value of a is bigger than 1, it's going to be a squeeze. And if it was less than 1, like 1/3 x squared, you went 1/3. So that graph would be like wider. All right. You're going to move up or down K. You're going to move left or right H. This is the tricky one, the left or right, because it's kind of the opposite of what you think should happen. If we go back to those examples here, this went to the right 4, and this went to the left 2. Some people think because it's negative, you should go to the left, but it's the opposite of what you think when it's in parentheses. So that's kind of what you need to know, and hopefully you wrote yourself a note in words that you will remember. Up or down is just what you think. Positive is up, negative is K, and then this is the A stuff we already discussed. All right, the vertex of the parabola, that maximum or minimum point, is going to be HK. This should make sense to you because let's look at an example. Y equals, let's say, x minus 2 squared plus 3. This is telling me I'm going to go to the right 2, up 3. So I'm going to take my y equals x squared, my normal mother function of y equals x squared. I'm going to move it to the right 2, and I'm going to move it up 3. So that's where this vertex is now moving. Now the formula is y equals x minus h squared plus k. H is 2, k is 3. The vertex set 2, 3, just like it was when I put it on there. I have had students refuse to memorize this HK thing. They just would rather draw a sketch of the graph every time, and that's fine. Okay. Parabolas have a line of symmetry. You should know this from Algebra 1. It goes right through the vertex. And that can give us a shortcut when we're graphing, because if you know one point, you will actually know the other point because of symmetry. And it will either have a maximum or a minimum. The A value is going to determine that, because if you have a smiley face, you will have a low point, a minimum value. And if you have a frowny face, you will have a high point or a maximum. And it will always occur at the vertex. Okay, so let's look at this one. Describe the graph of y minus 15 equals x plus 4 inequality squared. Okay, the first thing I like to do is get y by itself, so I am going to add 15 to both sides. Y equals x plus 40 squared plus 15. The next thing I'm going to do is figure out where my vertex is. That's telling me I'm going to go to the left 40, and I'm going to go up 15. So if I'm going to graph this, if that's 40, that's 15. That is my vertex. So if I'm going to describe the graph, I'll say the vertex is at maybe negative 40, 15. I would say it's smiling because A equals 1 here. So it's smiling, and it is a standard parabola. And I'd say maybe it's in quadrant 1, 2. It's in quadrant 2. I don't know what else we could say. Oh, I guess you could say the axis of symmetry would be at x equals negative 40. That might be a nice thing to say. Okay, lots of ways you can describe it. So let's talk about writing equations for a parabola. If the vertex is 5, negative 2, it opens down, and it's congruent to y equals 3x squared. what is the equation going to be? Well, this is telling me that A is going to be negative because it opens down, and it's going to be negative 3 because it's congruent to this y equals 3x squared. This vertex means I'm going to the right 5 and down 2. So how am I going to write this? Y equals, well, A is negative 3, x. Going to the right 5, so that's a minus 5. Don't forget your exponent. A lot of kids will forget the exponent, so be careful with that. And then go down 2 means minus 2 off the end. Okay, this one says the image of y equals negative 1/4 x squared under this translation of 10 to the right and down 2.5. A here is negative 1/4. So I have y equals negative 1/4. I'm going to the right 10. Don't forget your squared. Down 2.5. There we have it. Okay, the same holds true for absolute value, except you're not dealing with a U-shaped graph. You're going to have a V-shaped graph. Get y by itself here. Y equals the absolute value of x minus 2 minus 5. Okay, the absolute value of x starts at 0, 0, and it has that slope of 1. These are tricky to graph using the slate. So forgive me if it's messy. Okay, now I'm going to take it, I'm going to move it to the right 2 and down 5. The slope will remain the same. And there we have it. Okay, is there another way I could do this? Sure. You can always go down to the XYT table if you want to, and it will be just as efficient. You could also look at your graphing calculator if you need to. They want you to identify the translation that maps it. Okay, so that's going to be T. I went to the right 2, and I went down 5. That's the notation they're wanting. Okay, on this guy, they want you to graph these two. The first one is going to go to the right 3. Okay, and the A is 2. So remember, if you go over 1 from that and up 2, that'll be a point. There is an axis of symmetry here, and this is a parabola, so we're going to be a U-shaped graph. That's not too bad. I'm kind of impressed. Okay, on this one, when I subtract 3 from both sides, I'm going to go to the left one and down 3, and this is from the origin. Left 1, down 3, vertex is here, still that up to over 1 for the 1K point. This is a parabola, still not as good as the first one. Okay, so what's the translation that maps this first one to the second one? Well, it looks like I moved to the left 1, 2, 3, 4, to the left 4, so that's negative 4, comma, and then I went down 1, 2, 3. Negative 4, negative 3. Okie dokie, let's see. I think that might be it. Yeah. So we're going to do a lot of practice with this. I hope it makes sense. I really hoped you work through that graphing calculator activity because I think it'll help clear things up. If not, if you have any questions, mark them down. We'll talk about it tomorrow. Okay? Thanks a lot.